As climate change continues to destroy homes and harm lives, artificial intelligence and digital technologies are increasingly being recognized as a means of predicting and mitigating it. Governments, tech companies, and investors are showing interest in machine learning systems, which use algorithms to spot patterns and make predictions, suggestions, or judgments in real or virtual environments. In this video, we'll be looking at the tech predicting climate change. Before we start though, make sure to give this video a big thumbs up, subscribe to Future Tech Eden, and hit the bell icon for notifications. Now, without further ado, let's begin. Climate models. Climate models are computer simulations of the actual world that they can investigate today's climate and predict how it'll change. These models are based on basic physics and chemistry laws that describe how water and airflow heat up and cool the Earth, how pollutants react in the atmosphere, and how sunlight and infrared radiation interact with molecules. Millions of lines of code on powerful supercomputers simulate the physics and chemistry of the processes that make up our climate system. They forecasted and simulated global warming with amazing precision. Climate models conclusively demonstrate that global warming has been driven by human-induced greenhouse gas emissions since the Industrial Revolution, validating our understanding of the greenhouse effect, which has been known since the 1850s. They also reveal that the severity of many recent extreme weather occurrences throughout the world would be basically impossible without human intervention. Climate models are not used in isolation or without attention to their limitations, though. Scientists know that some models likely exaggerate global warming, while others underestimate it. This realization is based on our understanding of Earth's climate sensitivity, how much the temperature would warm if atmospheric carbon dioxide (CO2) levels doubled. Before the Industrial Revolution, CO2 levels in the atmosphere were 280 parts per million. We are now at roughly 415 parts per million. The most recent scientific evidence, based on observed warming, paleoclimate data, and physical knowledge of the climate system, predicts that if CO2 levels double, global average temperatures would likely rise by anywhere from 2.2 to 4.9 degrees centigrade. The vast majority of climate models operate within this range of climate sensitivity, but some disagree, predicting a temperature rise as low as 1.8 degrees centigrade or as high as 5.6 degrees centigrade. Representations of clouds and their interactions with aerosol particles are suggested to be the sources of certain models' biases. Researchers are beginning to comprehend these biases, helping us better understand the climate system and improve models in the future. With this in mind, scientists approach some climate models with caution, giving greater weight to estimates from climate models aligned with other scientific findings. So, how are climate models tested? Models created between 1970 and the early 2000s projected surface temperatures pretty well, but with how rapidly things change in this day and age, how can researchers be certain that today's models can reliably forecast the future? Well, models can be verified by providing data from many decades ago and checking if the model's forecasts, or hindcasts in this context, match historical weather data. Models are also compared with one another to assist researchers in identifying and investigating any significant disputes or variances. AI and its role in predicting climate change. With its effective use of data and algorithms, artificial intelligence (AI) has the capacity to analyze, anticipate, and reduce the danger of climate change. AI improves our understanding of climate change's effects across multiple geographical regions by generating effective models for weather forecasting and environmental monitoring. It evaluates climatic data and forecasts weather patterns, along with other socio-economic consequences of climate change, making policymakers more aware of increasing sea levels, ground hazards, hurricanes, and the like that may cause habitat destruction or even species extinction. Recently, the scientific community has begun focusing on climate informatics utilizing AI paradigms. As of now, though, more sophisticated research is still required to get the greatest benefits from AI in climate change mitigation. Ways artificial intelligence can address climate change. Researchers have achieved 89 to 99% accuracy in recognizing tropical cyclones, weather fronts, and atmospheric rivers, the latter of which may bring heavy precipitation and are typically difficult to recognize without technology. AI has proven increasingly important for forecasting severe climatic trends and patterns, and it has the potential to rapidly evaluate and simulate dynamic systems such as air pressure and underlying chemistry. It can also develop accurate models that can subsequently be used by scientists and researchers to make more robust decisions. Google, for instance, is now testing their own AI and machine learning algorithms to create near-instant weather predictions, highlighting the impact of extreme weather. Some people have already felt the consequences of climate change, while others may find it less tangible. Researchers from the Montreal Institute for Learning Algorithms (MILA), Microsoft, and Conscient AI Labs have employed GANs, a form of AI AI to model what residences would look like after being devastated by rising sea levels and more powerful storms. So far, MILA researchers have visited Montreal city authorities and non-governmental organizations keen to deploy the technology. They wish to create an app that will show people what their communities and residences could look like in the future with today's rate of climate change. But this will require additional data, and MILA stated that they want to ultimately allow users to share photographs of floods and forest fires to enhance the algorithm, improving agricultural output and optimizing the food supply chain. From estimating demand in hospitals to assisting farmers in their day-to-day jobs, AI is becoming more and more prominent. For example, with machine learning recommendations on when to sow crops, Indian farmers have been able to obtain up to 30% greater yields. Also, the Boston Consulting Group was able to use strong AI algorithms to estimate crop yields and generate risk assessments for French wine and spirits manufacturers. Identifying the source of carbon. Carbon Tracker is an independent financial think tank striving to achieve the United Nations goal of stopping the construction of new coal plants. It utilizes coal plant emissions data with satellite photography to persuade the finance industry that carbon plants aren't economical. With funding from Google, the organization's expanding its satellite photography and data collection efforts to also include emissions from gas-powered facilities and better understand where air pollution's really coming from. Additionally, AI can be used to automate the processing power plant data in order to obtain frequent updates on emissions. It also presents new methods for calculating a plant's impact by analyzing data on neighboring infrastructure and power use. This is useful for gas-powered facilities, which lack the easy-to-measure plumes found in coal-powered plants. Carbon Tracker can now calculate emissions for 4,000 to 5,000 power plants, gathering far more data than is already accessible and making it public. If a carbon tax is enacted in the future, this technology could help place a price on emissions and identify the people responsible for the most pollution. However, while continuous monitoring systems near power facilities may more directly quantify CO2 emissions, they don't have a global reach just yet. The downside of using AI. According to research conducted by the Massachusetts Institute of Technology, the amount of energy required to completely train and power a big algorithm is enormous, as much as 626,000 pounds or 284,000 kilograms of carbon dioxide, which is approximately 5 times the lifespan emissions of typical American vehicles. According to the International Energy Agency, data centers that process and store data from online activities like sending emails and streaming films currently account for about 1% of worldwide power use. But some predict that this will increase to 8% by 2030, raising concerns that this may lead to an increase in the use of fossil fuels. As a result, it's evident that AI isn't a magic wand capable of solving all of our climate-related concerns at once. So what's the solution? Ultimately, the employment of AI in combating climate change may be determined by how it's governed across borders. The AI Now Institute, a research center in New York University, has suggested green AI principles that will require complete transparency on a tech company's carbon, energy, and environmental impacts. It also recommends the integration of technology and climate policies. The European Union has indicated that it too is thinking about similar challenges, so rest assured that efforts to develop a solution with AI will continue for the time being. The opportunity clearly outweighs the danger. What are your thoughts on AI's role in climate change? Let us know in the comments below. And if you enjoyed the video, hit the like button, subscribe to Future Tech Eden, and hit the notification bell to be notified when we upload more content. Thanks for watching.